Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of the quadratic equation where we have seen what is a quadratic equation and how we can find the roots of a quadratic equation by using the factorization method and also by using the formula. So if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In this video, we are going to see the sum and product of the roots and also the nature of the roots of a quadratic equation. So let us start with today's video. Let us start by seeing the sum and product of the roots of a quadratic equation. The standard form of a quadratic equation is ax squared plus bx plus c equals to 0, where a is the leading coefficient and a is not equal to 0. Let us assume the two roots of this quadratic equation to be alpha and beta. So using the formula, we know the roots are minus b plus minus under root of b square minus 4ac upon 2a, where b square minus 4ac is the discriminant which we denote by capital D. So from this, the first root alpha can be written as minus b plus under root of d upon 2a, and the other root, that is beta, can be written as minus b minus root d upon 2a. Now let us see what would be the sum of the roots. So sum of the roots would be simply alpha plus beta, which would be simply minus b plus root d upon 2a plus minus b minus root d upon 2a. So if we simplify this, we'll be getting alpha plus beta as minus b by a. That is, the sum of the roots of a quadratic equation is given by minus b upon a, that is negative of the coefficient of x upon the leading coefficient. Now let us find the product of the roots. So the product of the roots in this case would be simply alpha times of beta, that is minus b plus root d upon 2a times of minus b minus root d upon 2a. Now again, when you simplify this, the product of the roots, that is alpha beta, would be simply c by a. That is, the product of the roots of a quadratic equation is the ratio of the constant term divided by the leading coefficient. This sum of the roots and product of the roots formula of a quadratic equation is an important one which we need to remember, using which we'll be able to solve many questions. So if we have the quadratic equation as ax squared plus bx plus c equals to 0, in that case, the sum of the roots would be minus b by a and the product of the roots would be c by a. Let us verify this by taking one example. Let us take this quadratic equation x squared minus 4x plus 3 equals to 0. So if we factorize this, the two factors would be x minus 1 and x minus 3, and this would be equal to 0. So the roots would be 1 and 3. So from here, the sum of the roots would be simply 1 plus 3, that is 4, and the product of the roots would be 1 into 3, that is 3. And this sum of the roots 4 is nothing but minus b by a, that is minus of minus 4 by 1. And this product of the roots is c by a, that is 3 by 1. So if we have a quadratic equation, we can write the sum of the roots as minus b by a and the product of the roots as c by a. Well, we can also find the quadratic equation simply by using the sum of the roots and product of the roots. We know the standard form is ax squared plus bx plus c equals to 0. Now, if we divide this quadratic equation by the leading coefficient a, in that case, this would be x squared plus b by ax plus c by a equals to 0. Now, this can be written as x squared minus sum of the roots. Why? Because sum of the roots is minus b by a. So b by a would be minus sum of the roots, and there was x here, plus c by a can be written as product of the roots. So if we know the sum of the roots and product of the roots, we can write the quadratic equation simply by using x square minus sum of the roots into x plus product of the roots equal to 0. Again, we can consider the same example to verify this. So if we know that the sum of the roots of the quadratic equation is 4 and the product of the roots is 3, then the quadratic equation can be written as simply x square minus sum of the roots into x plus product of the roots equal to 0, which is same as this quadratic equation. So if we have a quadratic equation, we can write this sum of the roots and product of the roots, and if we know the sum of the roots and product of the roots, we can also write the quadratic equation as well. Well, in all such cases, we need to keep one thing in mind, that is, whenever we are writing the quadratic equation from the sum and product of the roots, we have considered the leading coefficient to be 1. So in a question, if the leading coefficient has been given other than 1, in such cases, we will be multiplying that quadratic equation by that number to get the required quadratic equation. Also, if the roots are equal in magnitude but opposite in sign, in that case, the two roots can be considered as alpha and minus alpha. So the sum of the roots would be simply alpha minus alpha, which would be 0. And we know that sum of the roots is minus b by a. So minus b by a would be equal to 0, which will give us b equal to 0. So that means if the roots are equal in magnitude but opposite in sign, in that case, the coefficient of x, that is b, would be equal to 0. In a similar way, if the roots of a quadratic equation are reciprocal of each other, then the roots can be considered as alpha and 1 upon alpha. So in that case, the product of the roots would be simply alpha into 1 by alpha, which is equal to 1. And we know the product of the roots is given by c by a. So c by a would be equal to 1, which will give us c equals to a. So that means if the roots of a quadratic equation are reciprocal of each other, in that case, the constant term c and the leading coefficient a would be equal. So we can remember this condition, that is, when the roots are equal in magnitude but opposite in sign, in that case, the coefficient of x, that is b, would be equal to 0. And when the roots are reciprocal of each other, in that case, c would be equal to a, that is, the constant term would be equal to the leading coefficient. Now, let us see the nature of roots of a quadratic equation. The standard form of a quadratic equation is given by ax square plus bx plus c equals to 0. And we can find the two roots simply by using this formula, which is minus b plus minus under root of b square minus 4ac upon 2a, where b square minus 4ac is the discriminant, which we generally denote by capital D. So capital D is equal to b square minus 4ac. Since this discriminant is inside a root, so depending on its value, whether positive or negative, we'll be having different nature of roots. That is, whether the roots would be real or imaginary. For example, if the discriminant is greater than 0, in that case, we'll be having a positive number inside a root. So in that case, the roots would be real. And since we'll be having two different roots, so we can say that the roots would be distinct as well. So if the discriminant is greater than 0, in that case, the roots would be real and distinct. For example, say if I take this quadratic equation, x square minus 4x plus 3 equals to 0. So to find the nature of roots of this quadratic equation, one thing that we can do is we can solve this quadratic equation and we can find the roots, and seeing the roots we can say whether the roots are real and distinct or not. That is one way by which we can say the nature of roots. But we can also take the help of the discriminant of this quadratic equation to find the nature of root. In this case, the discriminant for this quadratic equation would be d equals to b square minus 4ac, that is minus 4 square minus 4 times of 1 times of 3. And this would be minus 4 square, that is 16, minus 4 times of 1 times of 3, that would be 12, and 16 minus 12 would be 4. Now, since this discriminant is greater than 0, so we can say that the roots would be real and distinct. Also, since this discriminant is a perfect square, so we can say that the roots would be rational as well. We can verify this simply by finding the roots of this quadratic equation. So if you factorize this, or if you simply use this formula, we can find the roots as 1 and 3. And by looking at the roots, we can say that the roots are real, rational, and distinct. So instead of finding the actual roots, we can simply take the help of the discriminant to say the nature of roots. In a similar way, if the discriminant is equal to 0, in that case, the roots would be real and equal. Because if d is equal to 0, then this part would be 0. So the only root would be simply x equal to minus b upon 2a. So if the discriminant is 0, in that case, the roots would be real and equal. Let us consider one example here. Let us take this quadratic equation, x square minus 4x plus 4 equal to 0. So here the discriminant d would be b square minus 4ac, that is minus 4 square minus 4 times of 1 times of 4, which would be 16 minus 16, that is 0. So here the discriminant is 0, so the roots would be real and equal. We can also verify this simply by finding the roots of this quadratic equation, which would be simply 2 and 2. And we can see that the roots are real and equal. In a similar way, if the discriminant is less than 0, in that case, the roots would be imaginary. Because we would be having a negative number inside this root, so we'd be getting imaginary roots. For example, let us consider this quadratic equation, x square plus 4 equal to 0. So from here, the discriminant d would be b square minus 4ac, that is 0 minus 4 times of 1 times of 4, and that is minus 16. So since your discriminant is negative, so the roots would be imaginary. We can also verify this simply by finding the roots, which would be x is equal to plus minus 2y, from which we can say that the roots are imaginary. Well, if you are not clear what are real and imaginary numbers and what is this iota, in that case, you can go through my video number and classification, where I have explained this part clearly, the link of which I have given above and also in the description box. So simply by finding the discriminant, whether it's greater than 0, equal to 0, less than 0, we'll be able to find the nature of roots of a quadratic equation. One more thing we all can remember, which is irrational and imaginary roots always occurs in conjugate pairs. That means if I have one of the root as 2 plus root 3, in that case, the other root would be 2 minus root 3. In a similar way, say if one of the imaginary root is say 4 plus 7i, in that case, the other root would be 4 minus 7i. So simply we can remember this, that is irrational roots and imaginary roots will always occur in conjugate pairs. So that's it for today's video, in which we have seen the sum and product of the roots and also the nature of the roots of a quadratic equation. In the next video, we'll be seeing the graphical presentation of a quadratic equation. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.